Welcome everybody. We're going to begin 10.1 arcs and sectors. This particular day is going to be talking about central angles, arcs, and arc length. We have a lot of vocabulary, so you might want to make sure you're ready to pause and write things down and get that vocabulary down, okay? So the first thing we have is a central angle, and that's an angle formed by two radii, so two radiuses, with a vertex at the center of the circle. So that's why it's called a central angle, because the vertex is on the center of the circle. Okay, so this is my angle right here, 95 degrees. That's formed with the vertex on the center of the circle. Okay, an intercepted arc is created by the central angle, the part of the circle that lies between the two segments, rays, or lines that intersect the circle. The central angle and its intercepted minor arc have the same measures. Okay, so right here we have the central angle. It intersects this arc right here. And notice that this angle measure here and this arc measure are the same. Okay, so the measure of my central arc and the arc measure of my intercepted arc. A circle measure, the total measure of a circle is 360. I think most every one of you guys know that already. Okay, a minor arc is an arc that's smaller than a semicircle. So you have a little minor arc, AB, and this is how you write it, is measure of AB. Okay, and right here, if the mark AB, remember our central angles are the same, so the measure of arc AB is 95 degrees. Okay, major. This should be major, not minor. So this would be a major arc, is bigger than a. Well, that's not very good. We'll try that again. Couldn't write that very good. This is a major arc instead of a minor arc again. Major arc is bigger than a semicircle. Okay, so the measure of ACB right here. So if this is 95. And this is 95. In order to find the measure of that arc there, we would take 360, and we would subtract that 95 degrees to find the remainder of the arc measure, so 265. So the rest of this here is going to be 265 degrees, and that would be our ACB. We have to use three letters to write major arcs, because otherwise AB would be this minor arc, ACB would be our major arc. Okay, I could also name it BCA. Okay. Okay, next up we have an arc measure. The measure of an arc is equal to the measure of its corresponding central angle. We kind of talked about that. And congruent central angles intercept congruent arcs. So if these two central angles are congruent, these two arcs here that they intercept are also congruent. Okay, congruent central angles intercept congruent arcs, and vice versa. So if these two arcs are congruent, the two central angles are congruent. All right, so we're going to put some of this to use now. So we have used this circle W. This central angle is 115. So what's the measure of arc? So no, it's not a segment, it's an arc XZ. So if the central angle is 115, I know that my measure of my arc is going to be 115 also. 115 degrees. Okay, so that's going to be 115 degrees. How about XYZ? So going the other way around, XYZ. And that's when we're going to just take our calculator. We're going to take 360 degrees, and we're going to subtract that 115. And that's going to give us 245. So over here, we're going to have 245 degrees remaining in our arc XYZ. Okay? How about next up here? We have all kinds of stuff going on here. So you just start piecing it together the best you can. Just one right after the other. So if this is 72, right? Here's my central angle, so that must be 72. Right? These are vertical angles right here, so this must be also 72. This is a diameter right here, so we know that 72 plus 87 plus this little arc must be 180 degrees. So I'm going to actually take my 180 degrees, 180, and I'm going to subtract that 87. Whoops, no, that's supposed to be an 8. And then I'm going to subtract that 72, and that should give me that leftover little arc right there. So that should be 21 right there. Okay? And then this one right here, this should add up to 180 also between 72 and X. So if I take 180 and minus 72, I should get 108. Okay, so now let's start to take a look over here. So what's the measure of angle UXV? So UXV, well, that's going to be also 72 degrees, right? What's the measure of arc ST? So look at my arc ST right here. Look at my central angle is 21, so this one must be also 21, so that will be 21 degrees. Measure of arc WV. So arc WV, I'll get a different color here. Here's my arc WV. This is my central angle, so that must be 108 also. So we have 108 degrees for that. Measure of arc TW. So let's look at TW. TW is kind of this bigger arc right here, so we can actually add 72 and 21 together. That would be 93. Okay, so that should be 93 for that whole arc. And then TVW. So that is probably a pretty big angle. Somebody used red. So whoops, I'm going the wrong way. TVW is going to go around here. So TVW this way. So TVW all the way around there. So this would be 87 right here. And this would be 72. And that's 108. So we have to add all those together. Okay. So we're going to have 87 plus 72 plus 108. And that is going to be my TVW is 267. Okay. So what I like to do is go and just measure and just put in all the numbers I can possibly find. And then I can start to put together the list of what's being asked. Okay. Now we have find the value of X. Well, we want to be able to find out what the central angle is here in order to find the value of X. So this is 15, that central angle there. This is 103. We know that much. This whole thing is 180. So 180 minus 103 should give us 77, right? And then, so what is that remainder right there? So this is 15. So let's take our calculator here and we're going to say, well, what is 180? Right? Because that's this right here is a line. That's a diameter. So that's 180 degrees. So if we subtract 77 and subtract 15, we should end up with that little 18 minus X central angle there. Okay. So we're going to go 180 and subtract 77 and subtract 15. Whoops. No. 180. Subtract. Oh my goodness. Seriously. 180. Subtract 77. Subtract 15. There we go. And we get 88. So this is 88 in here. Okay. So now I know that 18x minus 2 equals that 88 degree central angle. Okay. So I'm going to add 2. I get 18x equals 90. So divide by 18. So x is going to be equal to 90 divided by 18. And that's going to give me a 5. So the value of X is 5. Okay. All right. So now we're going to start taking a look at arc length, which is basically a piece of the circumference. So circumference is my whole distance around, right? Well, arc length is basically saying, what if this is 90 degrees? And what if I just wanted to find this little piece of this arc length right here? What's a measure, a piece of the circumference of that guy? Well, 90 degrees, would you all agree? Yeah, 90 degrees out of 360 degrees is 1/4 of that entire circle, right? And so this arc length must be also 1/4 of the entire circle. So we're going to use that ratio to help us find arc length. We're going to take the circumference and take 1/4 of the circumference, and that should give us that piece of that arc. Okay. Same thing if we had a diameter like this, right? That's 1/2 of my whole arc. Well, that's going to be 1/2 of our whole circumference. So we could take our circumference and multiply it by 1/2. Okay. And so we can use this over and over and over again. Okay, with this ratio. So what we're going to do is we take our arc measure here. So our arc length over our circumference is the same as our arc measure over 360. That ratio is the same, right? So that was 1/4. Then we take, this would be arc length over my circumference. So my piece of my arc length, piece of my circumference over my whole circumference. So we can kind of remember part to whole over part to whole. Okay. And so let's try to put this to use here. What is the length of AD? So I kind of make sure you understand which arc we're talking about. So this is the arc we want right here. Well, first we have to know what the central angle is right here, right? What's the central angle? Because that's that's going to give us our arc, our fraction of our 360. So we have to kind of subtract all of those other angles. So we get 360 degrees, subtract 104, subtract 43, subtract 73, and that's going to give me 140 degrees. Okay, so that's 140 degrees right here. So we take 140 over 360. that should be the same ratio as my arc length, x, over my circumference. Well, my circumference is 2 pi times 4, right? My radius is 4 right here, okay? So I can start to simplify this. My zeros cancel out, so I basically divide by 10 on top and bottom, okay? 2 will go into 14 7 times, and 2 will go into 36 18 times. So I have 7 over 18 equals x over 8 pi. From here, I can cross multiply, okay? I can take x times 18, which is 18x, equals 7 times 8 pi, which is 56 pi. Let's divide by 18, and x is equal to, and here we're going to simplify again. So we want to think of the biggest numbers that's going to go into both 56 and 18. 2 will go into 56, what is that, 28 times, okay? And 2 goes into 18 9 times. So 28 pi over 9. And I believe that's as simple as we get. So it's really important for you to know how to simplify that without just getting decimals, because they will ask you for exact answers in Excel. Okay, and exact means we leave pi in the answer, if you remember. Okay, if they ask you for an estimated answer, then that's when you multiply pi out. Okay, so you might want to try this, find the length of FD and see how you do, and come back and check your work. Okay, so here's my FD. What is the arc measure of that particular arc? So we need to find out what 80 plus 47 is. So 80 plus 47 gives us 127. Okay, so we have 127 over 360 equals my arc length x over, well, they don't give us a radius here. So there's not enough information on this guy. So I guess we'll skip on past this, and we don't have enough information to solve this guy, okay? So we'll skip on past that one. So you have an Excel in the Google Classroom. It's 10.1. Please bring any questions if you need to for arc length. I know that for some people that kind of trips them up and it's a little bit struggling. So make sure you bring some questions, and then I will see you all in classroom. Thank you very much. Bye-bye.